Um, Welcome, everybody. Thank you for coming to our Unstructured Data event. We organize these events to bring people together for collaborative learning and discussions about unstructured data and generative AI. So my name is Christy Bergman. I'm a dev advocate at Zilliz. We're the maintainers of open source vector database, Milvus. And we have some slides. But our CEO is actually here, and he's going to give a quick 5-minute introduction. Before he does that, who here has heard of Milvus or Zilliz? Yay. And of the people who have heard of it, how many are using it? Yay. And of the people who are using it, who wants to give a demo? Okay, I'll talk to you. Actually, you are giving a demo, right? Tonight. Okay. Anyways, yeah, so please hit me up if you're using Milvus or Zilliz. We want to bring you up here. Charles, would you like to? Okay.
Good evening, everyone. It's my great pleasure to see everyone join us tonight at this unstructured data meetup. I'm Charles Xie. I'm the CEO and founder at Zilliz. And also, I was a creator of the Milvus project. And our DevRel team really wanted me to talk about like the Milvus project and the company, but I want to speak for the community tonight instead of talking about our project and our company. So we know that, so let's talk about why we want to have this, we want to host this unstructured data meetup. So we know that modern AI has 3 pillars. It's about computation, it's about models, it's about data. So when it comes to models and computation, those 2 areas get pretty hot and get pretty crowded. And in the past 10 years, what I saw is that when it comes to data processing for AI, this area is highly underestimated. So, but if we take a closer look at the data we used to train these models, we build all these foundation models, we saw most of them are unstructured data. It's images, it's videos, it's human voices, it's user profile, it's geolocation information. Even in pharmaceutical area, we saw that people are working on 3D structure of proteins, 3D structure of molecules. And all this kind of unstructured data going to be a very, very important for we to build a foundation model, for we to build various kind of AI applications. And that's the whole purpose to build this meetup here. So this meetup is designed to foster innovations and collaborations in unstructured data management. And we really want to design this meetup as not only a place to learn, but more like an opportunity for all of us to share our ideas, to collaborate. And in the past 12 months, when we hosted this meetup, we definitely see more and more people coming. And again, thank you for coming tonight. And what we really see is that there are a lot of collaborations happening. So we see that the developers, they are sharing ideas, they're sharing best practice, and also they even build up new relationships, partnerships in the events. And we really want to we really believe in that the future of unstructured data management is not just in the technology itself. It's also in the community that we are going to build. And again, thank you all for coming, and hope you enjoy the pizza and the soda. And yeah, so if you want to so if you have any questions or if you just want to have a chat with me, please feel free to reach out to me, and I will be around all the evening. And again, thank you for coming. Oh, yeah, did I mention, I forgot to mention one last thing. So tonight we are also running a raffle. So please make sure that we register for the raffle and to win the surprise. And yeah, so thank you for coming, and enjoy the presentations of tonight. Thank you so much.
All right, so to enter the raffle tonight, we are giving away one ticket worth $399 for Generative AI Summit next week. It's going to be at the Palace of Fine Arts. So to enter the raffle, just go in, log into your GitHub account, and give this thing on the left a GitHub star, our Milvus project. And at the end, I'll run the raffle. And also at the end, I usually like to ask if there's anybody who has jobs, if you'd like to go ahead and announce those, so that, yeah, job seekers can find you. Okay. So today I'm going to just go over, I'm going to skip the introduction to RAG, and I'm going to skip over deep dive into RAG. I'm going to go straight into RAG evaluation. Okay, so just a quick reminder, where do the vectors come from? They come from these transformer models. The transformer models in the original was 2017, Attention is All You Need paper, it has two parts, encoder and a decoder. And the encoder is where the embedding models come from. So it's the next to last layer of that deep learning neural network of the encoder. Those are the embedding models. The decoder is the generator, and that's the chat GPTs that we know about. And sometimes they're just called LLMs. So we're going to talk about those two models. A very typical pattern is RAG. That's where you have your custom data, and you take your data, you pass it through the embedding model, which is like a big f of x. The x is your data, chunks of your data. The f of x equals y produces y as a vector, and those vectors are what you're going to put in a vector database. Then what you would do is if somebody asks a question, that question also gets embedded with the same embedding model into a vector, and then nearest neighbors search is performed, and it's a very fast calculation because now all we're doing is searching approximate nearest neighbors of vectors. What's retrieved is a chunk of text. You push that chunk of text as a context along with your question into the prompt, and then that goes to the second model or the LLM generator. And then hopefully what you get out is a more reliable answer from the LLM than you would have gotten without your custom context. So that's a quick review of RAG. And when we're talking about evals, remember that there's a couple different typical evals in LLM space. There's the arena, for example, the models evals itself. And that's, for example, LLM Sys is a really well-known leaderboard where you're going to have an ELO score, for example. And those are scores evaluating models. On the other hand, you've got probably a production system that's using generative AI, and you need to evaluate that. And that's what I'm going to talk about today. So the thing to keep in mind is that even though some model might score the highest on the ELO or the leaderboard, it might not necessarily score the highest in your system because your data is different. One of the theory things behind the modern RAG evals is this concept of LLM as a judge. I think I've mentioned it before, but there's this 2023 paper that came also from the LLM Sys team at UC Berkeley. We've got two Berkeley students speaking right after me. That found that GPT-4 is a really good critic. So humans are asked to judge whether an answer is correct or not, and the scores were things from chat to a whole bunch of different subject matters to general knowledge. And humans typically don't 100% agree with each other. We agree with each other about 80% of the time. That's called the Bayesian limit because humans are the limit for AI, and GPT-4 agreed about 80% of the time. So therefore, GPT-4 is considered as good as a human as judging. And this is an important idea because it's made evaluations a lot easier. We used to think that we needed thousands of labeled data, human labeled data, in order to do good evaluations. And now we found that we need, maybe 20 or maybe even less, like in the tens. So there are some known problems with LM as a judge, just want to point them out. For example, AIs are very good at measuring correctness and reliability. They're not so good at measuring whether you got every comprehensiveness, whether the coverage is complete or not. Another thing that's well known is, like, let's say you give it like 30 scores, which, I mean, even for a human is complicated to figure out a score between 1 and 30. But typically humans are more likely to pick the one on the left, the middle number is what humans pick, and the AI is more likely to pick the extreme numbers, the lowest or the highest. So I'm going to demo tonight a very quick demo of this open source package called Ragas for evaluating RAG. And what they do is they view the RAG system as a parallelogram. You've got your query, you've got the context of what's retrieved, you're going to have the generated answer, and then you're going to have a ground truth answer. And yeah, and so let me go back to that thing. So what's going on here is, like, some of these best practices are brought, as far as we know, are brought into the Ragas system. So instead of having numbers, it's going to be scores between 0 and 1. And instead of trying to ask for coverage, we can ask that on the context, but we don't ask that on the answer. And I think there was something else I wanted to point out. Oh yeah, so this demo I'm going to do today is I'm going to use GPT 3.5 to save money. GPT 4 is considered the gold standard, but as of just a few days ago, there's a new LLM model called Prometheus 2, or Prometheus Eval, and supposedly that is matching even 85%. So even better than humans of agreeing with each other, it's agreeing with humans. I don't understand how that's possible, but yeah, 85% of, agreeing, aligning with human judgment. So that's the newest model, which I need to update my demo I'm going to give you today. Oops, what am I doing? Okay, let me try to make this bigger. I might need to. All right, so I've got this notebook, and I think I'll just run it really fast. Okay, so new as of possibly even today, we have something called Milvus Lite, which is a way to connect with using your Jupyter Notebook or using Colab to our Milvus server. In this demo, I'm going to just go ahead and download our documentation, our technical docs, and I'm going to ask questions of it. And then I'm going to evaluate the questions that are asked of it. So that's what this part of the notebook is doing. I just downloaded 23 docs. Those are all of our technical docs. Then I'm going to connect, instead of connecting the way I used to connect either to our free tier Zilliz cluster or to a Docker. Now we've got this new Milvus Lite, so it's much easier. You just need to pip install the latest version, update, and then you just use this client from then on. And there's no more, we used to struggle with connection parameters. So now it's much easier. I can skip the cloud, I can skip the Docker. Okay, now I'm going to use just an open source embedding model. Sometimes I talk about how I choose those on the MTab leaderboard, but today I'm just going to grab this one, the M3, which is three modalities, dense, sparse, and and re-ranking. Okay, so I'm going to grab that from Hugging Face. So you can grab any open source embedding model. I'm going to create the collection. Collection is like a table in a vector database. Going to call it Milvus docs. I'm going to give it to the HNSW index. An index for a vector database is kind of like when you studied data structures in your computer science class, which are like designed for a very fast search. So linked lists or binary trees or all kinds of different data structures for fast search. That's what this is. So this is a hierarchical, shoot, all of a sudden. So it takes your data and puts it into hierarchical levels, and each level from the highest is the sparsest to all your data is the densest and the lowest level. And then because the top level is the sparsest, nearest neighbors is super fast. And then you jump down to the next level. And then you find the nearest neighbors again, and you repeat that pattern. So it's a order log n search time, which is much faster. So yeah, that's what this HNSW is doing. Hierarchical navigable small worlds, I remember. Okay, create the collection. I'm gonna do some a chunking strategy called HTML chunking, where I take the HTML structure itself and use that as the chunking strategy. Unless the thing within the H1 or H2 is too long, then I'm going to split it into 512 links. And that's because, oops, now I have a bug. I'll fix this later. Okay, I split it. And so what you'll see is those 23 docs are split into 569 chunks. Then I'm going to, oh, I'm running out of time. I'm going to take just like at the end. Okay, so yeah, actually, okay, I've got to wait for the chunking. So actually, this is a question that I get asked a lot of times, is like some people, like when they are trying to insert in the database, it looks like it's taking a long time, but there's actually two things going on. One is the inference calls to the embedding model, which is the first model we talked about with the encoder part of the transformer. That takes a while. And then usually inserting the embeddings takes like less than a second. But this is going to be the longest part. I actually wrote a blog a few weeks ago where I took and distributed and parallelized this embedding step. It's a perfect job for distributed computing because it's stateless. So you can get really fast speedups. So yeah, you can see that took almost a minute. And then versus inserting those into the database is going to take like less than a minute. Yeah, 24.24 seconds. Okay, now I'm going to ask a question. So what do the parameters for HNSW mean, for example? Execute the vector search. Remember, I have to embed that question and then run nearest neighbors. So here's where I did I ran the search and I set my top K as 2. So I'm going to get two results back. And then you can see these are the chunks. And now I'm going to take those chunks and I'm going to insert them into my context. So I'm going to just put them together. And another speaker here at one of our unstructured data events, his name was Lance Martin from LangChain, said that his studies showed that you should put your most important chunks at the end, not the beginning. So that's why I do this reversed thing. Set my LLM. Now it's my second model. Remember, there's the encoder and the decoder. So now we're ready for the decoder part. So we set the parameters for the decoder or the LLM, give it a prompt. And here's the fun part. You can try all kinds of different LLMs these days. I can run Llama 3 locally if I wanted. So that's what I ran here. Iuld also run any scale endpoints. And pick any of these LLM models. I'm going to pick Llama 3, for example. get an answer. I could pick Octo AI, Llama 3, just to see if there's a difference. I didn't import it. I'm going to skip over it in the sake of time. I also tried Grok. Grok is super fast because they have their own silicon LPUs. Oops, did I not import Grok either? Okay. Oh. Okay, I'm going to skip that too. I'm going to have to fix this. Okay, I tried Anthropic. I'm going to go back down to I tried Mistral with Anyscale. I think that's one will work. Okay, but this is not the main thing. I need to get back to my eval. So at this point, I've got my context. I've got a whole bunch of LLM generated answers. May as well run this one too. Oh shoot, what did I do? V5 turbo. Okay. All right. So now here we are ready to evaluate. So remember, Ragas needs your question, your context, your answers, and a ground truth. So what I did is Ragas is built on top of LangChain. So any kind of LLM or embedding that is supported with LangChain is supported with Ragas. So I have a golden data set here. I've only got 4. You probably need more like a dozen, but you can see my 4 questions, my 4 ground truth answers, what was retrieved. I've got like a simple context instead of the hierarchical, the HTML context. And then I've got like a whole bunch of different answers generated with these different LLMs. And I'm going to evaluate all this just to see what happens. I'm just going to run the context this time. Okay, so in this case, you can see that I got an overall score of 0.17 for the simple context and 0.38 for the HTML context. So that's a chunking strategy, which is a really big improvement, actually. And I can show you basically what's going on here is you assemble the Ragas data set in terms of what's the questions, what are your truths, what are your contexts, what are your answers, and then you go ahead and I didn't show where I set the critic LM. I'll send these notebooks out later, and then what I do is I based on whether I'm evaluating context or answers, I calculate an overall number. So in the case of the context, I have precision and recall, so I can calculate an F1 score. That's what this is doing here, this little section of text. Or if it's an answer, I can't do coverage of answers, so I can calculate an average of 3 things: relevancy, similarity, and correctness. So that's what's being output here in the Milvus Lite one. That's what these average numbers mean. And you can also print out all the details if you want. So you can see what my context F1 was for chunking strategy, the custom HTML chunking or symbol chunking. And just to make a long story short, this is what I end up with. I end up with, I can calculate a % improvement, which was 147 improvement by just changing my chunking strategy to being more appropriate to my data type. Versus if I try all those different LLMs, between the top one, which was surprisingly the Mixtral 8x7b Instruct, was the top for me. And remember, this is not the same as a leaderboard score. This is what works on your data for your AI application. And the worst for me was the Grok. And there's a trade-off here because the Grok is the fastest, so you're going to have low latency. But for my particular application here, it was a 21% improvement. So the bottom line here is, if you're going to spend time on your improving and refining one piece of your RAG, I would iterate now on my chunking strategy, because I can see with a few little iterations of chunking a strategy, I can get much bigger bang for my buck versus choosing a different LLM for the generative part. So yeah, that's it for me. Thanks. Because I'm my own host. So are there any questions? I saw one there. I'm going to take, yeah, go ahead.
So I'm wondering how the chunking deals with the, thank you. How is the chunking dealing with the structure in the data, and what are the assumptions on the unstructured data there?
Yeah, it really I really should have, it would be a different talk if I talked about chunking strategies, but chunking strategies for Gen AI, they're kind of like what the artistry that data scientists used to do for what was called featureizations, of like figuring out how to turn your green, red, blue into numbers. Basically, you're doing this now, taking your data, unstructured data, and turning it into chunks, because there's research that's called lost in the middle that says, like, if you throw everything that you have at once, you can, because the context lengths are getting longer and longer. Like now there are 1 million tokens, right? So you could throw everything into the context window of your second model, the LLM generator, but it actually ends up kind of confusing that model. So that's why the chunking is kind of an art. Is like, okay, you don't want that much data, but you probably, you need some smaller amount of data. And the right amount of data is kind of, yeah, it depends on the structure of your data. Yeah. So, well, that's what chunking part was.
Can I find the details of that strategy somewhere?
So in my notebook, I'm going to talk about what I used. If you've got an HTML page, quite often HTML chunking is better.
Thank you.
Yeah. I think we can take one more to you. Oh, let's give him the microphone.
Just a quick question about the Milvus Lite. Is it like an embeddable version of the database? Are you recommending this for local development, and then you kind of push things to the cloud?
Oh, okay. So Milvus Lite is meant for real rapid prototyping. So we've got all kinds of different flavors of Milvus Server. So Milvus Lite is our newest. It just came out today, and you saw it was one line. And it's meant for like collab or some kind of like rapid prototyping. We've also got Milvus that can run in a Docker or Kubernetes cluster. And then we've also got flavors of Zilliz. So Zilliz free tier, Zilliz serverless pay as you go.
Is using the light version consistent? Like if I use an embedding models and I get certain results, can I expect it to work the same if you push it to the cloud? If I move my data to the cloud?
I think, yeah, yes, but the Milvus Lite is meant for prototyping. It's not meant for like really large data. Yeah, so your same Python code though will work regardless of whichever Python server you've chosen. And that is one of the things that's designed into our product. Actually, our product manager is here. He probably wants to say a word. Okay. You want to say your name?
Yeah, I'm Jiang. I had the ecosystem integration and also this Milvus Lite and also our AI-powered search streamline embedding plus vector database offering. So thanks for the question and interest to Milvus Lite. Milvus Lite is designed to be like very easy to install, easy to use, but it's not supposed to scale you to billions of vectors, right? For that, you need Milvus on Kubernetes or Zilliz Cloud or commercial offering. So Milvus Lite is really great for prototyping, like the kind of the first mile in your AI journey, right? Once you got Milvus Lite, you can start using it with just pip install within seconds. And after that, if you have a more kind of production use case, you can scale to Milvus on Docker or Kubernetes or cloud, which shares the exact same API with Milvus Lite, so that your client-side code doesn't need to change. You just need to change the endpoint of the Milvus instance. Yeah, thanks for the question.
Thanks for that. Okay, so yeah, grab that I'll grab that. And then I want to introduce our next speakers. Actually, so our next speakers are Charles Packer and Sarah Woodard. Charles and Sarah are both, actually, sorry, it's just going to be Charles speaking tonight. But Charles and Sarah are both PhD students, graduate student researchers in the Berkeley Artificial Intelligence Research Lab and Real-Time Intelligent Secure Explainable Systems. Used to be called RISE. I think now it's called Skylab. Yeah, so Charles is going to speak about how to add memory to Gen AI chatbots, recommenders, and more.
Oh, I'm right here. Yeah. Okay. Hi, everyone. I guess I wanted to open with saying I only recently started kind of attending these meetups in SF. You know, I'm kind of locked away in a lab in Berkeley, or at least I was until recently because I just graduated. But yeah, I think right now, like the energy in open source AI in particular, I think it's something really special. And I wouldn't be surprised if in, 10 years, 20 years, we look back at these few years right now and really like think of it as the golden era of open source AI. So I kind of want to just encourage everyone to savor the moment a little bit before it's gone. And secondly, I also wanted to open with just a show of hands, maybe like who here has programmed an LLM agent before? Okay, seems like almost everybody. And among those who raise your hands, who has programmed like that LLM agent with LangChain? Okay, and then what about Llama Index? Llama Index also has an agents package now. Okay, less and less hands. And who here has heard of MemGPT before? Okay, more than Llama Index agents. That's good, I guess. Okay, so what I'm going to be talking about today is MemGPT. I guess because the audience isn't super familiar with it, I'll go over like some of the high-level concepts, but basically to like frame MemGPT in the general like LM space, MemGPT was this paper that came out last year from Berkeley, from me and a few collaborators, Sarah included. Sarah's actually not speaking, but she is here. So if you're interested in talking to her, you can find her after the talks. And it was really about adding memory augmentation to LMs. And so I guess so thank you for the intro. A lot of the information now is like a little bit redundant, but let's see. The most important thing here is maybe I have been doing my PhD for a long time. PhDs take a pretty long time. So I've been working on actually agents since 2017. And back then, we maybe would call this like the dark ages before ChatGPT. So 2017, that's 5 BC. And agents in 2017, like basically what I was doing in my PhD was stuff like this, right? So when people said agents, I guess who here like remembers these videos? Okay, most of us, right? So yeah, this is what we talked about when anyone was talking about agents. And now I think whenever someone mentions agent, it's immediately, you're thinking of LM agents, LangChain agents, I guess building agents yourself on top of the OpenAI completions API. And the high level takeaway from this talk, if anything, should really be that at least us at Berkeley, like our strongest conviction around LMs is that for LMs, memory is everything. So memory for an LM is the context, right? And when you think about an LM as just a compute unit, what is the input to the LM? It's the context. And that means that basically memory or context includes all of the programming we do around LMs today. So long-term memory, that was the focus of the MemGPT paper, but also tool use, in-context learning, RAG. All of these, basically everything we do today around LM programming is basically programming context. And another way to think about this is just, this is all one big memory problem. Okay, so yeah, has anyone here seen this movie Memento by Christopher Nolan? Okay, yeah, it's a classic, but I think often there's this analogy thrown around with LMs where people say, like if you're evaluating like how close LMs are to AGI, how close they are to being useful, you might say that like they're like an intern or something, right? Like the LM is like an intern, it's not going to be as useful as an intern. I think that analogy is like pretty bad, and okay, it's a little bit disrespectful to interns because I know we've all been interns, and we often like as interns we're better than the full-time employees or more valuable than the full-time employees. Another reason it doesn't really work is just like, I think for a much better analogy is this like amnesia analogy, where in many cases, like GPT-4 at least, it seems like GPT-4o, maybe not as much, but like GPT-4, if we consider that like the gold model, the reasoning ability of GPT-4 in many cases, if you set up the context just right, it looks good enough to really, do practical things and like add real value. If you're automating work, it seems like, GPT-4 should be able to automate a lot of work in a way where you can set up like entire economy of agents, all these agents working, you know, at an agent factory that's hosted in the cloud. But the real problem is that LMs just don't have memory. And like the way we program LMs today, I think amnesia is a great analogy for it, because it's like, you know, so if you haven't seen this movie, this guy has like amnesia every morning. I might be butchering this because I watched this movie a long time ago, but every morning he wakes up and he doesn't know what's going on. And he's kind of developed a system where over time he's like figuring out the best way to, in the morning, like refresh his memory of like what happened, or like his entire life story up to that point. And yeah, in the screenshot, you can see he's like tattooing himself, like writing notes. And the way we program LMs is pretty similar, right? We want to structure the context that we feed the LM in the most efficient way possible to pack like all the information the LM could ever need to generate the correct response. It's kind of like, you know, tattooing yourself everywhere to make sure that when you wake up in the morning and you have no idea what's going on, you can read something really efficient and immediately understand what you need to do. Yeah, so MemGPT, the project is really about addressing this problem, and addressing this problem with, you know, assuming that this is like the constraint, that you have some fundamental compute unit that's very good at, it has like human level reasoning in some tasks, but it has amnesia. So how do you design a system to program that context in a very efficient, meaningful way, you know, not ad hoc. It's not just, you know, LangChain code sitting on someone's computer, but it's like a real system, a real computer system that's generating this context. Okay, and, you know, related to memory, I think we can tie this all together with just thinking about like what the best AI products we have today. And I think for many of us, if we were thinking about like what AI products really like add value to our lives, so I know some of the like Copilot people are going to be talking, but a lot of us probably also use stuff like ChatGPT or like Claude. And yeah, at least for me, I think like the most high value AI product in my life, at least that I use on a daily basis, is ChatGPT. Yeah, so like if the models, I think when GPT-4 came out, a lot of us probably like in our minds were thinking of these things, right? We weren't thinking about, you know, a kind of glorified search engine. So yeah, I think why do we have AI that looks more like search engines and not AI assistants? Again, this is basically all boils down to memory. Okay, so yeah, Devin, everyone here remember this video? Okay, it went super viral. I imagine we're all kind of plugged in. So I think Devin and ideas like that, or like products like Devin, they get a lot closer to like AI assistant, right? And then I guess among those who saw Devin, who saw like this video that came out later. Okay, well, I'm not gonna get too much into this, but I think the key takeaway is that no matter what like the Devin video showed you, this problem is incredibly hard. And yeah, basically to summarize, LMs doing constrained Q&A type tasks, great. That's really like where they add value right now. Long range open-ended tasks, I think this is what we're probably in this room all the most excited about, right? But I think we can all agree that, you know, the tech isn't quite there yet, even if maybe it seems like the fundamental compute unit, the LM, is there. And to tie back again to ChatGPT, like, this is a screenshot from my own ChatGPT. This is from a while ago, but if you were to take a photo of this and zoom in, you'll see everything in my sidebar is related to one project, right? And if everything's related to one project, why am I not just sharing context between the windows? Why is it like this anti-pattern that when I use ChatGPT, I'm constantly like retelling the story of the project I'm working on, constantly like re-explaining, you know, why isn't there not a version of ChatGPT where everything is, you know, you have project context windows or something? And the answer is basically that we don't know how to do it. We don't really know how to get an LM to understand like hundreds of chats, millions of lines of code, and assemble this all in a meaningful way that it can like, it's at least similar to maybe how a human would have access to this information and like verbalize Q&A with you. Yeah, so what do we have? We have like RAG, we have lots of retrieval, multi-step retrieval. A lot of this stuff, you know, it's like baby steps in this direction. Long context LMs, I think I overheard in like the previous talk, we talked about long context LMs and how it, you know, it's not necessarily like the silver bullet. Cost and latency are the big things, but I think that if we just assume that like these like long context LM models will eventually like get driven to, like, they'll become commoditized, and like we all will have on our MacBook Pro M6 chip, we'll be running like a 70 billion model that has Grok level decoding speeds and has like 3 million contexts. I think the main issue is not really like long context being the bottleneck anymore. I mean, if long context was really the solution, then I think Devin would work so well that we'd all like be purchasing like Devin subscriptions And we all now we want to be programmers. We'd be like managers of programmers on our computers. But the truth is, it's not just about the amount of context you have. A lot of it is just about how you manage that context. So context pollution is, I think, the key word here. And this is why things like AutoGPT or Devin, like they don't work just because you have more context. Yeah, so the MemGPT project was basically the idea. The inspiration was just trying to move the needle from search engines to assistants. What is really required to get there? And the key insight in the paper, the academic paper at least, was like memory. Yeah, so I guess let's get a time check. Okay, so I think maybe for this audience, the most interesting thing might be to try to give you like a gist of what the key ideas from the academic paper were, because I think a lot of the ideas, so MemGPT is an open source GitHub repo. I encourage you to use it. I think right now, if you're trying to build like some sort of LLM app where it's an agentic app, maybe it's like a chatbot character AI clone, and you need those agents to have long-term memory. Like you just, that's like a constraint of your products. That in like if you're building an AI companion app, a personal assistant, that is actually a constraint. I think MemGPT is actually the fastest way to spin up an app like that. That's an open source project. So if that's interesting to you, definitely check that out or check out our repo. But what I'll go over today, or what I'll try to spend most of the time on, is trying to communicate the main ideas from the paper, because I think the main ideas from the paper, they're simple enough that you could also implement them yourself in LangChain, or if you were trying to build your own version of LangChain. Yeah, so this paper was called MemGPT Towards LLMs as Operating Systems. And yeah, you can see the figures here. It might be, I guess it's pretty big actually. So on the left, there's an example of how this memory augmented system might play out in a dialogue scenario. So you have a chatbot, it's February 14th, your chatbot says to your user, hey, how's James doing? Do you have any special plans today? Probably is pulling from the data from like the user profile that the user's boyfriend is James. Then the user says, actually James and I broke up. And immediately the LM goes back to its memory and it does a working, this looks a little bit blurry on my end, but like if you can't read this, it says working context dot replace boyfriend named James, and now it's ex-boyfriend named James. And then the LM follows up immediately with a back-to-back inference call and says, sorry to hear that, I hope you're okay, right? And the reason you want to do this is because if the user ever mentions James again, you probably don't want to say, how's your boyfriend doing, right? That's probably pretty painful. Someone, if this is real app, they might uninstall, very bad. On the right, we have like what is closest to RAG. So I think another thing you might want to take away from this talk is right now, I'm sure everyone in this room knows about RAG, building RAG systems. I think what we have with RAG right now is very much like a RAG 1.0, and where we're moving is a RAG 2.0 that a lot of people have been coining on Twitter or elsewhere, like agentic RAG. So instead of you having like an LM and then you have some RAG system, and the RAG system like injects, you have this hard-coded RAG stack, and then it injects into the context window, and that's like where the two paths merge. Instead, I think what will like really take root and become like the default way to use RAG is you have an agent that has tools, and those tools are the complex RAG stack. So the agent knows that it can use like this really crazy RAG stack you built as like hybrid search. It's using like 3 different vector databases or whatever. But that's kind of abstracted away from the agent. The agent just knows like, hey, if I want to use this like enterprise search tool, I'm just going to call out I'm going to call out to a tool, like a function call. And you're not going to really necessarily be connecting the RAG stack and the LMs at the token level. They'll be connected at like the tool level. Yeah, so MemGPT is really about memory via tool. So it turns out that like when you design a system to make memory work via tools, the entire system becomes very good at using tools. So MemGPT actually was like one of the first projects that implemented function calling across providers. This is back in like October, that didn't really exist that much yet. So yeah, MemGPT is also, if you want to create agents that use tools, like there's a lot of great code in there to make tool calling very robust. But yeah, the main insight is that if you have LMs like GPT-4 and you have tools, why not just to implement long-term memory, have memory be accessible via tools, like write to memory, read to memory. And that's like the very high level idea of how you connect LMs to memory. Yeah, so I think I'm going to, for sake of time, kind of breeze through this, but I'll try to touch on all like the key points that maybe are like easy to digest. So this is like the main loop. If you're building a chatbot today, this is kind of what you're doing. This figure was actually made last year, but I think everything is it's still the same. You have a user message that goes in to some system. In that system, you have an underlying context window, maybe 8K, 16K, 32K, 2 million, whatever. And then you output some agent reply, and then this entire loop comes back and you append to like a conversation. So if you're programming LLMs today, it probably looks like this. MemGPT, I think the two main differences are really the inputs are no longer just user messages. We have like meta inputs. We call them events. And that means that you can kind of make your LLM more, or your agent more reactive. So like a user message that comes in is just one kind of message. You can also send the LLM messages like if you hook it up to like a data fire hose, like your email or the agent's email, sorry, the user's email, then the agent can like get a ping every single time an email comes in, and then that agent kind of is aware that it can get different kinds of messages, user messages, emails, document uploads, system alerts, whatever, and then it can take an appropriate action. The other very important thing about like how we design MemGPT, and I think this is not MemGPT specific, if you were to build an agent system today from scratch, I would also recommend you do the same thing, is the outputs are always functions. So you restrict the output of the LLM to functions only. And I think this was a pretty, maybe like a risky bet when we made it back last year, but I think it's really paid off because as you've seen, there's been like incredible interest in function calling LLMs, and the foundation, like the frontier open weights LLMs just get better and better at function calling. Like every single revision of, I don't know, like a new spine tune or something, it's just incredibly good at function calling. So it's okay, I think, to just restrict your LLM to doing only function calls. I guess the other thing here that is non-conventional is that we kind of try to make a distinction between what is really in the LM context and then what's in like an external database. But these two things are fluid. And in the same way that, you know, you might have a phone that has only 4 gigabytes of RAM, you know, actually like every Chrome tab these days might take 1 gigabyte of RAM. You have 13 tabs open, but you only have 4 gigabytes of RAM. How is this possible? Well, it's because not everything is loaded in RAM, right? Some stuff gets paged out to the SSD on your phone or the flash disk. And it's the same concept with MemGPT. It's like if you have a context window that's 16K, you might have actually a ton of accessible tokens, much more than 16K or much more than 1 million or whatever, but they live on like a database. They don't actually live in context of the LLM. Okay, I think let's see, I might, yeah.
A good 10 more minutes left.
10 more minutes, okay. Yeah, let me just think about where I am here, okay. Yeah, okay, so I'm going to try to go over like these, I'm going to try to go over slides like this because they show you exactly what the inputs to the LM are. I think that's pretty important. I think it's okay. Yeah, it's one thing for me to just like verbalize about inputs and outputs, another thing for you to like really see them. So I'll make sure I touch on this. And then I think I might kind of skip over to more about like what exists in open source. So if you want to try this yourself, it's Apache 2.0 licensed, created at Berkeley, so you can just fork it, do whatever you want. We have a ton of great contributors, so I'll touch on that as well. So when I said the inputs are events, I really mean the inputs are always JSON. And then you also might have noticed, like when I said the outputs are always function calls, if you ever played a function calling, I also meant the outputs are JSON. So we have this LM system now where it's JSON in, JSON out. You could change this to be YAML or something, but I just think these days like LMs are a little bit better, or they're like a little more performant on JSON, even if it's less token efficient. Yeah, but basically, if you see like, usually in an LLM, the inputs are just going to be the user messages, right? And in this version of an LLM system, everything is JSON input. So if you have a user message, like the user types on their computer, how to undo git commit AM, probably a very popular query to ChatGPT, that will go into the LLM input as a packaged message that has metadata. And you do have to provide upfront some system instructions to the LM that let it know that it is receiving metadata. But the best models like GPT-4, Claude 3 Opus, anything like that, they're extremely good at this like role play style of input data. So they immediately kind of like understand, oh, I'm a system that receives like multiple styles of messages. And you can even try this out with like ChatGPT yourself. You just tell it, hey, for the next few messages, I'm going to send you like metadata style messages that have a type and a content. Other things that are like pretty cool you can do once you set up the system is you can imagine like if you're connecting MemGPT to a vector DB and you upload a document, but you want your LM to basically understand that a document was just uploaded and now accessible by the LM. What you can do is you can have like a ping that gets routed to the LM as soon as the data finishes uploading that sends the LM a message like the document upload is just finished and it's accessible by this tool. So then when you use the LM, you no longer have to say, you know, I uploaded a PDF into your vector DB that's accessible via this tool. It just knows automatically, and you can have a very natural conversation. So I think this style of making LM inputs more meta will also kind of be something that, yeah, you'll see in basically every single agent framework going into the future, maybe past like 6 months from now. So the outputs also JSON only. If you've ever written like function calling code, you recognize very much like this style, this syntax where you have functions and parameters. Those are going to be like the outputs of the LM. And since this is pretty familiar to most people, probably I'm not going to go too much into it, but yeah, this is how you would access data that exists outside the LM. You give it tools that allow it to like page in information. And I guess the last thing here that I'll touch on is we have this concept of in-context memory. I think this is pretty important because if you think about like how you interact with other humans, right? When you like, if you ever see your friend like walk down the hallway and you haven't seen them in a few years, like you immediately have some stuff in your mind about like the last time you talked to them, what their name is, what they last looked like, all this information that's like very front of mind. And that friend might ask you a question like, you know, hey, do you remember that time? Or like, do you remember when X's birthday is? Or you're going to whoever's wedding? And those questions might not like be, the answers might not be front of mind, but like the way you had your initial interaction with that person, that was very much informed by this front of mind information. And I think you really need to do the same stuff with LMs, where you need to have some stuff in the memory of the LM, the immediate memory, where it doesn't need to like page into external context with a vector database that kind of describes like the general information of what should be going on. Like if I'm an LM, I'm role playing as this, or I am a helpful assistant or whatever, and the user I'm conversing with is this, their hobbies are this, you know, their user data is whatever. So this is basically like a read-write memory block that exists in context. Okay, and I think I'm going to basically skip all the way to the end here. Yeah, so that was kind of explaining the key ideas in the paper, and hopefully that has maybe inspired some of you who are building LM agents to like make different design choices or try some new things. Basically, MemGPT as an open source project has really evolved beyond this paper and is now really about building LM agents. So agents that have long-term memory management, have access to external data sources, which is kind of what you would call RAG, but it's not read-only, it's also like read-write, and calling and executing custom tools. So like I said, tool calling is extremely good in the MemGPT framework, primarily because memory is implemented using tool calling. Yeah, so this is where you would go to find, it's basically github.com/cpacker/memgpt. That's where the project is. We basically like to call it like the open source platform for building and hosting LM agents. This project now has a very strong focus on self-hosting. So we basically want to make it so that you can like run your own agent server and then interact with those agents over the internet. And those agents like live on your server forever. They don't just, you know, as soon as the program exits, everything, all the beautiful conversations you had together with your agent, they evaporate into the ether. No, it's like if you ever close the process, everything gets written to a database. It's all persisted in Postgres or whatever, or SQLite. Yeah, and we have like a real robust REST API, and that's like the main way you would communicate with these agents. So you'd send messages over REST API, and yeah, that's the kind of the intended developer experience. What that looks like in graphics is basically you as a developer might have some application. This could be like some crazy web app. It could just be like a very simple thing you're running at home. It could be something that's not even chat. We have developers that are building like voice interfaces instead, where like there's no chat, it's just voice via VAPI or something. You communicate with REST APIs. As a developer, you deploy the MemGPT service. It's a multi-user, multi-agent service. So when you make REST API calls, you tag with the user ID and the agent ID, and then you can route the backend to like OpenAI, Cohere, Grok, whatever you want. You can self-host it via LM. And there are two main ways as a developer you would interact with this service. You'd either open the developer portal, which looks very similar to platform.openai.com. It's just a free version of that. And you can also use a CLI tool, which is pretty popular for people who just like to chat. And yeah, I will briefly, this is actually pretty good because it's still very low resolution, but On the left is a blown up version of like what this developer portal looks like. So you can basically pop in here if you have a running app and you have like real users using it, you can actually like pop this developer portal open to kind of monitor the chat or like edit the state of the agent. So if you notice something's going wrong with like a user chat, you can just like pop this open and like go ahead and like fix the agent state. And there's a tool builder where you can just upload arbitrary Python code and the agents can run it. And just this final slide, so I'll go quick. We recently added a Docker integration. This is basically how I would recommend you run MemGPT. So if you have Docker somewhere on your laptop, service or server or whatever, definitely use Docker. It's the easiest way to get this running. We have token streaming now. I think the main thing about token streaming that's important to know as a MemGPT developer is we implemented token streaming in a backwards compatible way where you basically should just code your front end to assume that the backend supports token streaming. And if it doesn't support token streaming, like you routed off of Grok and now you're using like Anthropic, which as of a few days ago or a week ago didn't support token streaming with function calling, it's all okay because we will like correctly fix the backend for you to like imitate token streaming, but the tokens will just come in batches. Yeah, so this hopefully makes things a lot easier for people trying to build on the API. And the last thing I'll say is we included this proxy chat completions API. So chat completions is stateless. What we're talking about with agents is stateful, but we did add this proxy API. So there are a lot of services out there like Vappy and LiveKit that only speak chat completions, but they're super cool because they allow you to like connect your agents to voice services. But yeah, sadly, they don't really speak stateful APIs. So we did add a proxy. So you actually can now connect MemGPT to voice services. So one of our favorite developers, they basically have this like patient chatbot where the patient will talk to the chatbot via voice, but then a nurse can like monitor the dev portal and like whisper to the agent's ear and say like, oh, you forgot to tell the patient to do X or Y. So you can have like multimodal connections to your agents. And yeah, I'm just gonna wrap up there. I'm not sure if there's time for questions or if I'm way over, but.
I think we can take a couple questions. So that sounds very exciting. Are there any questions? Oh, I see way over. Okay, I'm gonna go over there. What if your data gets too big? Are there considerations for that?
Yeah, so because everything is in Postgres, we kind of trust that Postgres scales. So if you don't have problems with Postgres, then you shouldn't have problems with MemGPT. But yeah, if you really are doing some crazy workloads that have crazy amounts of data, then you might need to consider a different backend. Yeah.
Hey, how does this work when the JSON that's on the input to the model has like a non-text values? So let's say like a number or timestamp, like H5, something like that.
I see. So are you talking about like what would happen if you include metadata in the JSON that is like it's still Unicode, but it's not like English text or something, or? Yeah,
I have like some, practical entity. I don't know, like a house on Zillow or like a complicated entity. And maybe most of its properties will be numeric or something that doesn't like tokenize well, basically.
I see. Yeah, I think if the fundamental tokenizer of the like LLM backend you're routing to doesn't support the text that's coming into the event stream of MemGPT, then you'll have problems in the same way that you would have problems sending that data to that LLM provider anyways. But general stuff that's more just like metadata, actually the default implementation of MemGPT, I think we like tag every single message or event with a timestamp, and it's like a pretty long timestamp. It's like the full, I forgot what it's called, ISO format timestamp. And like frontier LLMs really do understand. They can like do math on basically like understanding when the last message was, and they might say, oh, hey, I noticed you haven't logged in a while, because they can read the timestamps backwards and like sees the delta in time, things like that. I'm not sure if that answered your question.
Partially, yeah.
Okay.
Do you have some content on how well the timestamps actually work? Because like if you have a number on the language model input, it like tokenizes it per digit or something, right? And then it kind of gets garbled from there. So, but yeah, it's the limitation of the underlying language model, not the framework, right?
Yeah, that's a great point. I think like with the timestamps in particular, I think at one point in time, we did do like relative timestamps, where we basically like all the timestamps, because like, a big thing I really want to stress with MemGPT is like all the data is stored in a model agnostic, like canonical format in Postgres or a SQLite, whichever database you're using. So that means that the timestamps are stored as like datetime objects, which is like the correct way to store them in Postgres. So you can kind of format them however you want, and you can write a custom formatter. And I think we did at one point, which is like a relative formatter that formatted to basically message received now, message received 2 days ago, message received like 2.5 days ago, a month ago, that sort of thing. So I think if you were, I think that's what you're describing, like the issues with tokenizers and timestamps. That's actually a great reason to actually maybe for us to reconsider like adding that as a default again. Yeah.
Cool. Thanks.
Great. So are you going to stick around and if there's more questions?
Yeah.
Okay, great. So yeah, if you had more questions, you can ask Charles afterwards. So our next speakers, let's thank our speaker. Okay, so our next speakers are Idan, Gazit, Senior Director of Research at GitHub Next, and Cole Bemis, Senior Software Engineer at GitHub Next. Idan leads the developer experience research at GitHub Next. He can usually be found geeking out about the web, data visualization, typography, color electronics, and sewing. He lives in the East Bay with his family and surrounds himself with a rotating cast of half-finished projects. Cole is a quick and relentless learner with a passion for usability and best practices, always eager to learn new skills, tools, and technologies. And they're going to be speaking about Copilot Workspace, what it is, how it works, and why it matters. Welcome.
Thank you. Hi, how are you all doing? We made it. It's the end of the day. Is this the last talk?
Yes.
Success. Okay, so hi, my name's Idan. This is Cole. We'll be your entertainers for the next 30 minutes. And we're from GitHub Next. Who here has heard of GitHub Next? Okay, some of you. Nice. We have friends in the audience. We definitely didn't plant them there ahead of time. So GitHub Next is GitHub's long bets team. What started out as the office of the CTO, back when we had a CTO. And by long bets, I mean things that sound ridiculous, but if they work, could really come to define our entire business. Like, what if we had AI that could help us write code, right? At the beginning of Copilot, that was not like a sure thing. In fact, that was a fairly ridiculous thing. Like, we were not sure that it would work. But because it did work, now that's like a whole thing with a lot of users and a lot of revenue. And I hope GitHub remembers the revenue part for a long, long time and keeps us employed. We were the original team behind Copilot, and then Copilot for CLI, Copilot for Docs, Copilot for PRs, a million other Copilot things. And most recently, if you've been sort of keeping up and you've seen the news about Copilot Workspace, that's the thing that we've launched most recently. Oops, that's not the right one. That I've shown you, Cool. GitHub Next explores, where are my notes? Okay, so GitHub Next explores how to turbocharge software developers as they go about the job of software development, right? There's a lot of news out there about agentic things, right? And everyone's asking this question of like, oh, is this coming for my job? No. The reason like that there are power tools out there does not mean that we build fewer buildings, we build more buildings, right? We couldn't build skyscrapers without power tools. I mean, we could, it would just take way too long. So our job is to figure out how to give superpowers to developers, how to make it easier for developers, not just to author code. And I think that's one of the things that's sort of a misconception with generative AI today is people are like, oh, it's all about generating the next line of code. And that was definitely true for sort of the early days with Copilot. But the bigger part of the job of software development is not actually writing code. It is reading code. It is understanding code, right? If I am thrown into a code base I don't know, and I'm given a task, and I don't even know, sort of where to start with that task. What part of the code base is the code that deals in this thing? Where does it live, right? That's actually a much bigger problem for me as a software developer than actually authoring the 20 lines of code that I need in order to make the change. First, I need to know where to make that change. So, so how do we do this at Next? It says that we're a research team, but the reality is that we're a lot more like a prototyping team. Our job is not to be philosophers burying Google Docs being like, oh, we think that this would make for a good experience. We think that this would help software developers. We have to actually build the thing and put it into people's hands and then be like, here, use it. Do you think it's good? So very frequently we're sort of messing around, trying things. First, we're persuading ourselves. Then we turn around and we need to persuade the rest of GitHub. There's quite a lot of developers at GitHub, a few thousand of us. And then, we can go to things like public technical previews like we do with Copilot Workspace in order to let more people in more code bases with more frameworks and more languages really sort of exercise the thing and make sure that it's actually delivering value. Did we actually figure out something good, or are we just bullshitting ourselves, which is the most common trap in developing products, and particularly with AI, where how it works on my laptop means absolutely nothing for how it'll work on my laptop in 5 minutes, let alone on your laptop. So I want to say that there's some special sauce, a little bit about, GitHub Next, like, what is it that we do and how is it that we go about this this process. But the truth is actually pretty boring. We're just a very small team. We're fewer than 20 people. Everyone on the team is on the more experienced end of the spectrum. So, when we go out and try to do things, we probably have a relatively good sense for what's interesting or where value might lie. And by now we've earned a lot of trust from the rest of the business, which I think is not to be taken for granted, right? If you're trying to boot up sort of an innovation function, sorry, I know that sounds super corporate, but an innovation function at a larger business, the first job you have is to demonstrate your relevance to the business, right? And so that was very much sort of the first challenge that we had to achieve. We have a lot of skills on our team. How we go about building sounds like the hard part, but the hard part is actually, what do we build? I can spend the next 15 minutes with, I bet, literally any of you in the audience and come up with 3 years worth of shit to try, right? Things that we could build and maybe they'll be good. The hard part is not actually building those things. I mean, it's hard, but that's not the hardest part. The hardest part is, which of these things do we build? We only have 15 people or 20 people, and we don't have infinity time, and we have to move faster than the rest of the market. So the first job at Next is making good decisions about what to build. So yeah, so our process is all about bet making and letting other people use it. In this case, I'm going to be talking a little bit about Copilot Workspace. I'll do a demo, and then I'm going to hand it over to Cole, who's going to show you a little bit of the messy but awesome backstory of how Copilot Workspace came to be designed the way that it is today, that people see it on the web. The core sort of emotional story of Copilot Workspace is, cool, we have Copilot, and Copilot can make these little suggestions, right? It can suggest a line or a couple of lines, a function, right? But what if I want to do a task, right? Like fix a bug or implement a feature. That is a much, much larger scale of suggestion than Copilot could ever possibly deliver. How do I get the model to deliver a suggestion on this much larger scale without going completely off the rails, right? I think the previous talk about MemGPT was very interesting because it's grappling with this exact same problem of how do we keep the models on the rails? And so one way to go about it is be like, oh, I'm going to supply the best context, locally sourced, artisanal, handcrafted context, and through that try to elicit great response from the models. But the reality is that even that alone is probably not going to be sufficient. I need to have some points of steering in the middle that allow me as the developer to tell the model, no, you didn't understand what I wanted, or no, you didn't understand exactly how the system works today before making changes, or no, you didn't handle this edge case that I expected you to handle, right? Without those points of steering, we're just sort of closing our eyes and hoping we hit the target. And so Copilot Workspace has this flow that instead of going directly from task to code and sort of betting the house on one hand, it goes from task to spec, right? Just like you would as a software developer or maybe a product manager, say like, okay, here is the way it works today, and here's the way that I want it to work in the future. And that's the first point of steering. What is it that, how does it work? How should it work? And in natural language, you as a software developer can go in and edit this. You're going to see all of this live in a minute, and you're all going to cross your fingers for me that the demo works. And once you're happy with the spec, right, you click OK, and it generates a plan. And the plan is a very, sort of bullet point, again, natural language list of like, in these files, I'm going to make these changes in order to go from what was to what should be, right? And only once the developer says, I like this plan, right, after editing it, do we actually go and synthesize the code, right? And by having these two moments of steerability, I'd say maybe steerability is sort of the dance partner for the memory from the previous talk, right? By having that steerability, we dramatically increase the chances that we're not just pulling the lever on a slot machine, that we actually get back something that we want to have. Nope, not going to go there. I'm going to go here. I'm going to go here and I'm going to show you this. This is a website. This is actually a live website for a different project that next called Monospace, which is some fonts. They're awesome fonts for coding. But I want to change something in this website, right? I'm looking at this website and we have these samples here for all these different languages, and this is really cool, but I like Rust, and I don't have a Rust sample here. And so this is an actual Copilot workspace on an actual website doing the actual work. And so there's a couple of entry points. First of all, you can start with an issue. So I created this issue on the repository, and I want to add a Rust example. And so the code playground has tabs that show examples for a number of languages. I want to add a Rust code sample. I want to, make sure to add a dependency on the syntax highlighter so that it actually highlights the code for me, and then, add the actual tab in the sort of list of languages, right? And I can click, you see here this button, open in Workspace. I can also just at the root of the repo, click on the sort of like code thing and then Copilot and then just type it in myself. But here I'm going to start from an issue. So I click open in Workspace, and through the magic of caching, this happens very quickly here. But normally it takes a little longer than that. It builds a spec, right? It's gone from this issue. Is this big enough? Is this legible? If something is not legible, then shout at me. Be like, that's not legible. Cool. So it's taken my issue and it's generated a specification. Is there a Rust code sample? No, there isn't. And the package isn't in the dependencies. And the file with the code samples doesn't have a Rust code sample. And the playground doesn't have like a tab for the thing, right? So it's correctly sussed out what's missing in order for like this future state to be true. And it's proposed the mirror image of the thing. But if it hadn't understood either the current state or the future state that I'm reaching for, I can go in and click on this and edit it. But I'm not gonna, because through the magic of caching, oh no, by clicking on it, have I broken the cache? Oh no, well, worst case, I'll have to switch to a different tab. So here it's actually gone ahead and built that plan for me, right? Like I need to add this dependency to the package.json. You can see there's actually sort of like bullet points for every file that it's identified. And in fact, when I I didn't show this in the spec phase, but I can actually show like, here are the files that it consulted or sort of in order of importance, while figuring out what that specification should be. It looked at these things. And we don't have, this is straight up GPT-4 Turbo. We don't have special magic extra large token context. So we're doing a bunch of special sauce things behind the scenes to sort of chain requests together in a coherent fashion. That's not easy. And once I'm happy with this plan, I click implement. And because I touched the thing, I broke the cache. Oh, well. Okay. Now I'm going to do the Julia Child thing, and I'm going to, so you can see it's starting to generate it, but it's slow. I'm going to do the Julia Child thing and switch. Oh, look. And in this other thing, it's, wait, where's my implementation? Oh, no. Maybe this one? Yes, cool. Okay, so you didn't see that happen. A cake emerged from the oven just like I said it would. So it's taken this plan and it's synthesized the code so I can actually go and look and see what code it generated. And it actually generated, like a good Rust sample, and it imported the thing like I asked it to. And here at the bottom, what file is this in the font playground? It has added a Rust sample. So this is cool. But this is also editable. Like, if I'm not happy with this, I can go ahead and type. But more than that, I can even like open a terminal and then npm install. Let's do that. Because what I also want to do is to make it very easy for me to see the changes that I've made and validate that they've actually happened. So, okay, it's npm installed and npm run dev, and typing with one hand is hard. And then I have to click on that, and it's going to flip me over. And in a minute, the code space that's in the background is going to boot up and get it ready. And I'll be able to see my website and see that it worked the way that I expected it to. And now we're all going to wait for computers, which is our favorite job in the world. Go faster, little computer. It's okay. I'm doing great. Oh, come on. That was not 1 second. It lied. Okay, I have a working website, and oh, look, I've got a Rust tab right here. So is this the greatest feature ever implemented in the history of features? No. Okay, but you know what? A lot of software development tasks look exactly like this. They're not these big lift architectural things. They are, somebody handed me a ticket and told me to go fix a thing or do a thing, and now I'm gonna spend 3/4 of my day figuring out which files I even need to touch in order to like get this task off my back, right? And so that is Copilot Workspace in a nutshell. And I think this is the moment where I slide over here and yes, advance to the design evolution. So you see the messy start and how it came to be the way that it looks today.
Thank you. Hi, everyone. I'm Cole. I was one of the designers on Copilot Workspace, and I'm going to talk about the design evolution from idea to the technical preview that we shipped a few weeks ago. I know Idan said that we don't have any magic sauces, but I think one of our magic sauces is that we care a lot about design and UX, especially for our AI products. So hopefully this gives you a glimpse into how we think about the design. So from idea to tech preview, it was a pretty iterative process, but I'm going to talk about a few key milestones along the way that give you a pretty good idea of how we got to where we're at right now. So the first milestone is the initial prototype. And here's a screenshot of the first UI for Copilot Workspace. It was called Extract, Edit, Apply back then. This was a little demo put together by Don Syme. And the reason I love this screenshot so much is because it's very representative of how next projects start. They're very organic. We don't have big, long, like Google Docs with a bunch of theory or a big Figma file that has every decision laid out perfectly. We usually start with pretty rough prototypes. We show it to each other, we iterate, and we often have to build the thing in order to figure out what to build next. So that's how this started. The next big milestone was when we introduced Primer. Primer is GitHub's design system. Prior to working at Next, I worked on the design systems team at GitHub for about 4 years. So of course, the first thing I did when I joined Next was I rewrote the whole front end of Copilot Workspace using Primer components. Here's a before and after. If you look closely, you can see that the name of Copilot Workspace changes a lot over the timeline. So it used to be called GitHub Kitty Hammer. Then at this point, it was called Semantic Workspace. And most of the things that I do here is just swap out components to use Primer components, and we get a lot for free. We get a lot of the GitHub colors, the typography, and the accessibility features for free just by switching to Primer components. The other benefit that we get is a better story. It's easier to sell this product internally and externally
when it actually looks like the rest of GitHub. You can kind of see how this might fit into GitHub someday. So I worked with one of our designers, Skylar Anderson, and we kind of iterated on this initial design. And this is a screenshot of the UI that we previewed at GitHub Universe last November. The next milestone was when we switched to a task-first workflow. So kind of midway through the Copilot Workspace projects, we ended up having 2 workflows to end with code. So it started with this topic-first workflow, and the best way that I can describe this is if you're working with another engineer and you go up to them and you say, how does the authentication work for our app? They'll come back and tell you how the authentication works, and you say, well, I actually want it to work this way instead. And they take their understanding of how it currently works, what you said it should work, and then they write a plan and they produce the code. That's essentially the topic-first workflow. The issue-first workflow is if you came to them with a GitHub issue and you said, can you please complete this issue? They might do the same thing. They'll think about how it currently works and what they need to do to get it to meet the issue requirements, and then they'll give you some code. The problem with having these 2 different ways of using the app is it makes it really hard to design and give like the right affordances to like guide the user through the process. So we decided to consolidate and just make it so you're always starting with a task. And a task can be an ad hoc description of some work you want to do, or it can be a GitHub issue, which is essentially just a task that you've stored in GitHub. So this simplified a lot of things for us in the UX. The last big milestone we had was when we shifted to this timeline UI. One of our designers and engineers named Turkel, he joined the team, and he had this idea to restructure the UI around this timeline, which made it very clear kind of where you are in the process. So you can see what you've done, it's indicated in green. You can see what you're currently doing. You can see that on the right here, the plan is generating, and you can see where you're going. Eventually, you'll come up with an implementation. So this is that timeline UI in the context of the actual application. And this is essentially what the UI looks like right now in the technical preview. Another thing that's nice about this timeline UI is that it scales down to mobile really nicely, so you can actually get real work done on your phone using Copilot Workspace. So that's kind of a high level of how we got from idea to technical preview. And a follow-up question might be, what's next? What are we working on right now? We have a lot of like kind of experiments in flight, and I've got plenty of ideas for where we might take this. But we're really in like gathering feedback mode. So we're dog fooding it a lot, and we're on Discord looking for feedback from all of you. So please join the waitlist for access. And when you get access, please join our Discord and give us feedback. We are checking it every day, and we're using this to kind of guide the direction for where Copilot Workspace goes. So thank you.
Cool. Awesome. Okay, we're gonna do, how much time? Do we have some time for Q&A?
Yeah.
Sick. Okay, let's grab these chairs. We'll sit over here, and then you'll lob questions at us. Spicy questions, please. Only the spiciest.
I think it's spicy. Because you're working on files individually, it seems like you could parallelize a lot of the calls, but in the UI, everything seemed to be sequential. Is there a reason you've chosen to do that, or did I just misunderstand the way the UI looked?
I think my sort of very soft answer there is remember that we can't fit most repositories into one context window. We have to make multiple calls. And like I said, we're sitting on top of 4 Turbo, not yet 4.0. And we don't have like the special, secret abilities to do something with the model. We're sitting on top of the same model you are. So it might be possible to parallelize some things, but in order to maintain coherency across calls to the LLMs, that's probably the sort of the biggest impediment. Right now it's slow. Like you didn't see how slow it was. The generation part that that I sort of like swapped the ingredients for the cake in the oven, that took a few minutes. Which is fine if you're doing a job and you're like, okay, I'm gonna go get a coffee, come back and oh look, it's done. So clearly this is an area that we're very keenly interested in making faster. And there's a lot of different things that we can do there, including maybe parallelization, but then there's that tension with like, how do you maintain coherency? So one request respects the contents of the other requests if you do it all in parallel.
Makes sense, thanks.
One of the things we're also exploring to make the generation faster is how we can get the model to produce diffs reliably. So instead of giving us back the whole file, even if it only touched one line, can it just give us back the one diff? And I think that'll have a big impact on how fast it feels.
Hi, so I just wanted to know what level of context does the issue that you created need from the developer? Like how deep should it be so that it can create a really robust plan and really figure out what the plan needs to be?
It really depends. It's kind of an art. You get a feeling for the tool as you use it. You can start pretty vague. And the nice thing about the process is it's iterative. So if you give it a task and it gives you a specification that's completely wrong, you can start to nudge it in the right direction. And then over time, you learn like what context it likes.
All right, thank you.
Yeah, not shown in the demo, but you can go back and edit any previous phase and regenerate all the downstream phases. You can even chat. There's like a little like, conversation icon where you can like natural language say like, no, not like that. Do it like this. And it will go one step back, alter the spec, alter the plan, whatever, and then downstream regenerate the things. So regeneration is good.
One quick follow-up. Does it also have memory?
No. The question was, does it also have memory? And the answer is no.
Question for Cole. So you did a great job with the redesign. You're also dressed really sharply. So I'm wondering if I start dressing sharp, will I also be able to design like you?
Yes. Yeah, absolutely.
I think that's it. I'm curious, what does dog fooding look like at GitHub?
Well, we use Copilot Workspace to build Copilot Workspace. So basically any task that I have to do, I will use Copilot Workspace first. And if it doesn't do great, then I'll probably file an issue and maybe fall back to VS Code. But at this point, I would say a lot of my work now starts in Copilot Workspace.
Okay, cool.
Yeah, it's important to remember that the end result, I didn't show off this part either, now that I think about it, which is kind of the whole point of Copilot Workspace. At the end of the process, there's a create pull request button, and it creates a pull request. And that pull request is just a pull request. There's nothing fancy about it. And if I don't love the code that's on that branch and I want to take it another direction, no problem. I clone the repo, check out that branch, and get to work in whatever tool I want. There's nothing that's like locks you into only using Workspace. It's just another development environment.
Okay, let's take one more question and then we need to get to our next.
Spicy questions.
So when it falls short, do you find that it's better to revert and try again or continue onward? Like, does it behave differently under those circumstances?
Yes. I think it really depends.
Yeah, I mean, it depends on where it falls short. Once you've been using the tool for a little while, you get a feeling for like, is it super off? Maybe I need to go back and redefine my task. Is it like only a little bit off? Maybe I just need to add something to the plan to get it to work. Or if it's just like 1 or 2 lines, I'll just edit it directly like inline. So it really depends on how far off it is.
Yeah, the iterability makes it easy to sort of like check out these alternate futures. If you're like, this isn't exactly right. If it's like totally off, then I'll go all the way back to the issue and I'll rewrite the issue in order to add things. In fact, one of the demos that we did a couple of weeks ago, we had like a volunteering event at GitHub. And one of them was like sort of like Ruby for good, write code for some do-gooding benevolent organization. And it was adding pagination to something. And it wasn't an issue that we wrote. We just rolled up to like a random open source repo, and it was like, add pagination to this thing. And that issue is written really well. And so when I click, open in Workspace, it totally one-shot it. But it got a little confused about which dependency to pull in or something like that. And so then I sort of went back, and you can actually edit the issue in Workspace. So you can, without sort of affecting the original issue, which was not my issue and not in a repo that I control. So yeah, there's quite a bit of control there to be able to like sort of nudge it harder if you need to.
One thing to add too is I really like Copilot Workspace as a thought partner. And in that use case, the hallucinations are actually a feature, which is kind of interesting. So if I have a very vague idea of what I want to do, I'll just type that into the task and I'll see what it hallucinates, and I can kind of create by reacting to what it made up. So if it's right, I'll just continue with it. If not, I'll correct it. But it allows me to kind of like elaborate on my thoughts.
Oh, well, thank you. Let's thank our speakers and and will you be able to stick around later if people have more questions? Okay, cool. Okay, so we have one more thing tonight. We have a Milvus community demo. I'll just let you introduce yourself from WordWare.ai.
Good evening, everybody. Yes, I am Robert. I am from WordWare. That's WordWare like software, because a lot of people apparently didn't get that first time. So we believe prompting is the new programming. And if this comes up on the screen, so you can see it as well. So what does that mean? Well, at the core of all these AI agents that you're seeing, they're all prompts. And they're prompts that call other prompts, that call other prompts, that use tools. And at the end of the day, you get some really amazing thought processes out the other end. And like you can distill expert knowledge into repeatable, reusable agents. And I think what we're seeing right now is a whole load of agents in the software development space. And that's because engineers themselves are domain experts in building software. But what we're not seeing is agents across the broad spectrum, the long tail, in fact, just across the entire industries of the GDP of the world. And that's what we want to help change. And now to be a little bit more concrete, because you guys are not investors, you guys are just people building cool stuff. Let me show you how you build cool stuff in WordWare. And you can think of WordWare a bit like a new programming language. And it's a programming language where the core abstraction is the prompt. And then you can put together these prompts and you can build any AI agent, any workflow, whatever it might be, you can build them in WordWare. And so you can think of us a bit like the orchestration layer of prompting, a bit like LangChain, but infinitely better. And because I don't have two hands, I was going to do a Hello World demo from scratch, but no one wants to see a man type on a keyboard very, very slowly. So the only button I'm going to press is the slash. And now anyone who's a Notion user should recognize this straight away as the slash command that gets you to use tools. And because of that, we're very usable by the PMs, by the CEOs, by the domain experts. You don't need to be an engineer to do prompting. And in fact, you're better off if you're not an engineer, because you know more about the subject matter that you're building. So we have customers that are doing legal tech, and they really know a lot more about how to analyze a contract, or the PMs know a lot more about how to analyze a contract than the engineers do, which is unsurprising. None of us speak legalese. We speak Python and JavaScript, but we don't speak clauses. So this is what the hello world looks like. And basically a prompt is abstracted into a function, and you can define inputs, and then you can write some prompt, and then you do a generation. And a generation is an output from a language model. It can make use of any of the best language models. We want to be as frictionless as possible. We want you to optimize your cost, quality, and latency for whatever use case you have. And now if I run this, and I typed in GitHub earlier because I'm a pro, we'll get a hello GitHub, it's great to see you today output from the language model. Super boring, but hopefully gives you a little bit of the concept of what's going on. Now, if you really wanted to, you could share this directly with your team, and they could be as powerful a prompt wizard as you are, or you can deploy it and trigger it from your API. But given this is an unstructured data meetup hosted by Zilliz, we are going to demonstrate how you might use that inside your prompts. And so what I did was I set up a cluster, I set up a pipeline to ingest some data, and I ingested a contract that we got recently because we just got into YC. But woo! But this contract's rather long, and I don't want to read it, and I signed it anyway. So no, we did read it. We did read it. Don't worry. But we can ask various questions of it, because and you won't be able to feed this contract into an LLM. Maybe Turbo Gemini 1.5, but even then, you end up with this problem of context. What did Charlie say earlier? Context pollution, correct. Yes, that was the word. You end up with too much data in there that the questions don't get answered well. So you're better off using some kind of RAG. And so with WordWare, you can do code blocks. You can hit out to any API you want to hit out to, and therefore it's super easy for us to integrate a little fetch request to hit the Zilliz database where we had ingested our YC contract. And then we can do a very simple vanilla RAG. So we literally hit this prompt as if it's a function, which is a function that hits the RAG. We get the results and we reference those in the output with the at. Oh, there you go. Can't even type one letter with the at command, which is just like in Notion, you're trying to mention an output value. And then we answer the question. And just a very simple, what you see is what you get. And so if I ask something like, what date does the MFN kick in? So we can raise money before YC get to take more of our money, more of our company. We get an answer, and we get the answer because it's fed that question directly into the vector database, pulled out a bunch of clauses from the contract, and given us an answer. And that's all well and good. It got a decent answer, but if we ask a slightly harder question, it might not succeed. And especially the reason this RAG doesn't normally succeed is because the question you're asking of the system is often not in the same embedding space as where you'll find the answer. And anyone that's built RAG knows this like fairly well. So what you want to do is transform that query into something that you're likely to find in the source data, so in our contract in this case, and then answer the question. And so that's what we do right here. So we kind of go from a vanilla to a spicy advanced RAG, and advanced in inverted commas, it's still super basic. And the first thing we do is we pass our question into this transform block. And this transform prompt then has a little bit of a chain of thought process. And it basically decides to generate a first chain of thought that's like, what would be the right clauses to look for? And then it outputs that and then turns that into a short snippets that will embed much closer in the embedding space to the query that we have. Or I'll be more concrete. It will embed much better in the embedding space to the type of clauses that will contain the answer to the query we have. And then it will pull out more relevant details and be able to answer them. And so now if I run this, we will first transform the question. We'll then query with both the transform query and the original question, because it gets better answers that way, because I tried it a few times and it didn't always work. But that's why we did it that way. We'll include that context in the prompt, and then we'll generate an answer. And so now if I run this, and I think, actually, let's have a look. So I asked a slightly harder one. I was trying to find out a bit about pro rata. So I was like, do they get to invest in our next round? If so, how much? And we can see this is still running. So it takes a little bit longer to do these multi-hop agent-based chains, but you tend to get better results. And so here we extracted a load more legalese that no one wants to look at. And we basically got an answer that they have participation rights, and they do get to take some amount, but apparently our RAG did not work well enough that we did not get the exact percentage out. But what you can see here is the result of the transformed query. And so, given a little bit more prompt engineering, not just the sort of little bit of time I had before this demo, I'm sure we could get a much better query transform and be able to answer a range of questions. So that is using RAG inside WordWare. And yeah, hopefully it kind of shows you how you can chain together prompts, how you can get better outputs from your language models through chaining. And now, because I don't have too much time, I'm going to do one more demo on building an actual agent. And so here we have an agent that will write code and run code to create its own tools. And that's really useful because once you've built a tool, you can then reuse it. And so we give it the ability to use Google search and to write code and run code. And it's set up as a React-based agent, which is a very, very simple agent. It's a thought, action, input, observation loop. And we run that literally specified as a loop in WordWare, where we first generate a thought, then we generate an action. Then we have an if statement that decides if that action's a Google search, we'll run this Google search, which is just another little bit of code that hits out to Google. And if the action is run code, it will literally run that code and print the logs to the context. And it will keep going until it's done. And so I've asked it, what's the current Bitcoin price? It's like, hey, I need to find an API to find the current price of Bitcoin. It's going to do a Google search for the Bitcoin price API. It's going to get these outputs from Google. And it's going to then decide that CoinGecko is a good choice. It's going to write the code to query CoinGecko, get the output. And huzzah, if you're investing in Bitcoin, you'll know it's been going up over the last few days because I've been running this demo and it had been going down. So you must be happy. Cool. And the last one, I'm just going to show how you can chain a whole load of things together. And so you build these narrow task-specific agents that are insanely useful to very different use cases. And so what we did was we use a multitude of models. The first is an online model that will fetch data from the web. And we're trying to learn about a person to create a personal website for them in one shot. We then run another online model, which is by Perplexity, to populate even more details. And then we combine both those descriptions and summarize them to get a good summary of the person. We then try and generate a prompt for Stable Diffusion to feed that into Stable Diffusion. And we then write a poem about them. We read it out with 11 Labs, and we create a website from scratch and host it. And all of this was created by my co-founder, who's sitting over there, in about 10 minutes, because it's that speedy to iterate on WordWare. And so I fed in Charles Packer, who was doing the MEM AI talk, and it kind of found a bit of information about him. It then used this inside Perplexity to find even more information about Charles. And then because that's a lot of information, we then summarize it into a single bit, create an image. And because we don't want to wait 30 more seconds, here's one I made earlier, learning from the best. And if we have sound, we don't have sound, but there is a wonderful poem being read out by 11 Labs about Charles and how amazing he is at memory. So that is WordWare. That is where we're at. We're building narrow task-specific agents for everybody. So they're to be built with domain experts in collaboration with engineers. If you're struggling with slow iteration cycles at your companies because you're a PM and you think you can do better than engineers, or you're an engineer and you're annoyed with the PM sending you prompts in Slack, then hit us up. We're also hiring for founding engineers. So if you're an incredible builder, come see me. I'm going to be walking around waving and talking to lots of people, hopefully. That's all. Any questions?
Thank you. I think we have time for one question. Okay, people are going to ask you one-on-one afterwards. Wonderful. Thank you and congratulations. So thank you everybody for coming tonight. Thank you to all our speakers. We always end this with, we hope you learned something new tonight, or met somebody new, or changed your mind about something. And as promised, I'm going to do the raffle. And thank you for your, yes. For the demo. Oh. Awesome. And while I'm getting set up, is there anybody who has a job announcement that they would like to do? Okay, hand you that.
Hello, everyone. I'm Deep Barot, founder of Context QA. It's a Copilot for software testing and automation. So we are hiring UX designer and AI ML intern. So yeah, if you are looking for, yeah, please email at deep@contextqa.com. Thank you.
Thanks. All right, so I've got my, let me just double check. I'll do a refresh here. Oop, okay, a new name. So I'm just going to call you by your GitHub name. And then come up to me afterwards so I can get your email. All right. Real Victor, are you here? Okay, I might have grabbed a few GitHub names a little earlier than our time slot. Wee Tang. Okay. Remove. Okay, I'll just close this. So we spin. Seamus 2340. Oh. Kirkstra? Oh, shoot. I didn't know this was going to take so long. Oh, no. Okay, we moved that guy again. Oh, I didn't mean for this to take so long. Caplum. Yay! All right, so we have this place until 8:30. So yeah, please find each other, and thank you for showing up. Thank you for coming.